Okay. This is exercise for question 17. So that the following function is a spline function. So you have, okay, the top function is actually, we denote it as a S node. Then so S node is actually x cubed minus x squared plus 3x plus 1. And S node is only defined, okay, in the interval 0 to 1. Okay, and then we'll find the first derivative first. 3x squared minus 2x plus 3. Now find the second derivative. 6x minus 2. Okay, similarly, okay, for the bottom function, we denote it as a S1. S1 is defined in the interval 1 to 2 only. So means K is actually you have 0, 1, 2, 3 point, 3 okay. And then for cubic spline is actually every 2 point. Okay, every 2 point if use Lagrange, okay, 2 point is actually you have a linear function. And then if total 3 point you have actually is a quadratic, but here, okay, every 2 point we make it as a cubic function. And then, okay, so this is at 1 to 2, another 2 point, we have another cubic function. And they are actually piecewise, okay, smooth because your SK, the S node at the point 1 must be connected with S1 at the point 1. So that it is actually connected. So now, okay, I'm going to find the first derivative for S1 function. So you have negative 3x squared plus 10x minus 3. And find the second derivative for S1 function. So negative 6x plus 10. Okay, and then, okay, to show it is a spline function, your condition 2 is actually, you just need to show the S node. Okay, but okay, this question they didn't give you here. You look at this one. We don't know the fx, so you cannot show condition number 2 because, okay, the real data, okay, the real data is a x, this is a f, okay, means 0, 1. We know, okay, actually you have the when x is 0, 1, and 2, but we don't know what is the f value. We don't know the fx. So we cannot show condition number 2. So we can, show 3, 4, 5, and we try whether number 6 can be achieved or not. So we can, since we don't have the fx, we cannot show condition number 2. We can show 3, 4, 5 here. 3 is actually, number 3 is actually the S node, at 1. You must show S node at 1 is actually, you have to show S node at the point x equal to 1 will be equal to S1, 1. So that, the cubic spline is connected. They are connected together. Hence you just plug in x equal to 1 into the S1, S node. So when you plug in x equal to 1, you have 1 cubed minus 1 squared plus 3 times 1 plus 1. This is your S node 1. What is that? So this is 1 cubed minus 1 squared. This one cancel. So you have 3, plus 1, which is 4. Let's check the S1, 1. Plug in x equal to 1 into the function S1. So you have negative 1 cubed plus 5 times 1 squared minus 3 times 1 plus 3. So this is negative 1, okay, plus 5 minus 3 plus 3. So you have, okay, 5 minus 1, which is 4. Okay, therefore, S naught 1 is equal to S11 equal to 4. So this is proven. This is actually condition number 3. Number 3. Checking here. Condition number 3. Okay, S1 at the point x equal to 1 equal to S naught at the point x equal to 1. Okay, we have, okay, proof condition number 3. Number 4 is a, okay, just, okay, now condition number 3 to number 4 is actually you just replace it by first derivative. Number 5, you replace it by second derivative. Okay, hence, okay, you go to the, okay, the first derivative. So mean condition number 4. Okay, you calculate S naught prime when x equal to 1. You have 3 times 1 squared minus 2 times 1 plus 3. So this is 3 plus 3, 6, 6 minus 2, 4. Okay, and then we see the S1 prime when x equal to 1. You have negative 3 times 1 squared plus 10 times 1 minus 3. So it's actually 10 minus 3 minus 3. So minus 6, answer is 4. Hence, okay, you have shown that actually first derivative for S naught when x equal to 1 is equal to, okay, the first derivative of S1 when x equal to 1 equal to 4, 2. So this is proven. Okay, and then later on you need to show, okay, conditions number 5. Condition number 5. Okay, you have to look back. So this will be S naught double prime when x equal to 1. Okay, find back the second derivative function, 6x minus 2. So when x is 1, 6 times 1 minus 2, we get 4. Okay, and then S1, okay, second derivative for S1 when x equal to 1. So you have negative 6x plus 10. Negative 6, so x is 1 plus 10. 10 minus 6, okay, is 4. Okay, again, okay, you managed to show that the, okay, second derivative for S naught when x equal to 1 is equal to the second derivative for S1 function when x equal to 1 equal to 4. So this is proven. So 3, 4, 5, okay, is proven. Okay, we are going to check whether this is a, okay, natural cubic spline. If natural cubic spline, the second derivative, okay, x naught is a starting point, xn is an ending point. So in this case, okay, question, starting point, this one, x equal to 0, ending point is x equal to 2. So mean you plug in, okay, condition 6, I put it here. Condition 6, you have the S naught, okay, starting point, which is double prime, 0. So the second derivative for S naught when x equal to 0. So plug in 0 into 6x minus 2, you have the answer is negative 2. Okay, and then you plug in the second derivative in the S1 function when, okay, at the ending point, so you have negative 6 times 2 plus 10. Oh. So it's negative 12 plus 10. This is negative 2. So this is not, okay, natural cubic spline because you cannot get here. If natural cubic spline, the second derivative at the starting point will equal to the second derivative at the ending point and must be equal to, okay, 0. But in this case, what you obtain, okay, when x equal to 0, okay, to use the starting point, you must, okay, starting point is actually belong to the S node functions, huh? And then the ending point is actually inside, okay, the range of the S1 function. That's why to evaluate the ending point, you must use the S1. Okay, to evaluate, okay, at the starting point, you have to use the S node. That's why the S node double prime, we plug in here. We have -2, -2. So hence, okay, this one is not, this is not natural cubic spline. Because it's only this one. But here because we don't have the fx, we cannot show this one. So okay. And then 2, 3, 4, okay, 2, 3, 4, 5. If it's 2 also cannot, okay, show because we don't have the fx. We managed to show 3, 4, 5. Okay. Hence this is a, okay, this is a, okay, is a only cubic, is a spline, cubic spline function. Cubic because each function is a cubic, okay, polynomial. So this is a question 17. Question 17 from exercise 4. Okay, do you have any questions here? This one? Okay, this one also similar. Okay, 17, 18 similar. Then 9, okay, 19 will be a little bit where you need to find the k. Find the value of k, show that the function sx is a spline cubic function. Cubic spline function. Okay, any question that you want to ask or not? If not, you look at the question 19, 18, you may try yourself similar. Okay, this is 19. Okay, when you want to find the value will be, I think, similar to just now example 2, 3, maybe 2, 3, 4 there in the slide, in the video just now. Okay, to find what is the value of the k, we may use k the condition number 3, mean the S node 1 will be equal to S1 1. Mean okay, S node is here, this is a S1. Because their connecting point is at x equal to 1. So you can use a S node when x equal to 1 equal to S1 when x equal to 1 here. Okay, then you just plug in your x node, okay, S node is here. So your S node 1 is actually plug in x equal to 1. So k times 1 plus 1. So this one you cancel. So we have this one is actually k plus 1. Okay, and plug in 1 into the function S1. So you have negative 1 cube plus k plus 2. Okay, 1 squared minus k times 1 plus 3. So negative 1 cube is negative 1. So 1 squared is 1. So plus k plus 2 minus k plus 3. Okay, simplify and equal the S node 1 to S11, then you can find the value of k. So here k minus k no more. So you have 2 minus 1 is 1, 1 plus 3 is 4. Okay, and then since the S node 1 equal to S11, okay, S node 1 you have simplified, you get this is actually k plus 1. S11 is 4. Okay, hence the K equal to 3. This is question 19. Okay, you can check whether it's correct. Question 19. Three. So this is question 19. Question 20. Okay, given the following data in table question 20 here, estimate F7 and F14. So you notice 7 and 14. 7 in between 4 and 9. And then 14 between 9 and 16. So you can use an interpolation technique to estimate F7 and F14. Okay, question A using Newton, divided difference polynomial, Newton divided difference interpolation. B using natural cubic spline. Okay, I think 8 minutes. Okay, we may construct the Newton divided difference first. Where is my Excel? Okay. Okay, for the natural cubic spline, you have no choice. You have to do it manually, except that table. So but here we do the Newton divided difference first. You have I, you have the X. This is the F. Okay, here I just put this is a first. Okay, first Newton divided difference. Then this is a second. Okay, you have 3 data only. So you have only up to second Newton divided difference. 0, 1, 2. Okay, the X is 4, 9, 16. So 2, 3, 4. So this is the F is actually the 0 Newton divided difference. This this is what we denote as a Fi square bracket 0. This is a Fi bracket 1. This is a Fi bracket 2. This is the first Newton divided difference. This is the second Newton divided difference. Okay, and then you just need to key in the formula in the I row for first and second. So for your F0 level 1, the formula is a F1 level 0 minus F0 level 1 divided by X1 minus X0. Okay, and then the F0 level 2 is a F1 at level 1 minus F0 at level 1, divided by 0 plus 2 will be x2 minus x naught. Okay, then you can key in the formula, okay, in the Excel quickly, where you have, okay, make sure you have a bracket. This is a F1, okay, minus your F naught divided, okay, numerator and denominator you must put bracket, okay, in Excel because it is not natural display like your calculator. Okay, then you can copy it down. Okay, for second level is this one. Okay, mean the next row in the previous column minus the current row in the previous column divided will be the x2 minus x naught. Okay, and this one I didn't round anything, so if you do, okay, using calculator in 4 decimal place, the answer will be, okay, running a little bit. And okay, you want to estimate, okay, estimate what's the value just now? Let's say F17. So F7. Okay, and then okay, using Newton divided difference is actually your F7 approximate by, okay, I up to 2 is approximate by P2x. Okay, your P2x is actually equal to the F naught level 0 plus the F naught level 1. Level 1 you multiply with one term, which is x minus x naught. Okay, plus level 2. So x minus x naught, okay, multiply x minus x1. Okay, level 2. Level 1 multiply one term, level 2 multiply two term. Okay, and then you key in, okay, in the Excel directly. Okay, or to make it as a template later on, I want to estimate, okay, 14 quickly. I put the x here, put 7, okay, first, and then, okay, F naught 0 is here, plus F naught 1 is here, multiply, okay, x here. This is okay, I don't put constant, doesn't matter because I didn't copy the formula to any place. Okay, if you copy the formula, then you have to make it constant, but in this case I'm not going to copy. Okay, then so this one minus, okay, x naught is here, plus F naught 2 multiply, okay, x here, minus x naught multiply, okay, x minus x1. Okay, Excel of course is easier than the classic calculator. Classic calculator, you cannot click that cell, you have to key in the location of that cell. So you get this one. This is for F7. Okay, you can check the answer. Question 20, 20A, 2.63. This is for F7, 2.63. Okay, if I want, let's say, now, if I want, where is the F1? F14, F14. Then here I change to 14. Here I change to 14. Get 3.7619. Okay, where is it? Okay, 3.75. Here give K 2 decimal place. 3.76. Okay, the answer set there. Okay, and here because I didn't round anything. Okay, the answer maybe I think last should be used 3 decimal 3 or 2. I'm not sure. So this is a Newton divided difference. Okay, do you have any question? Here we revise back a bit the Newton divided difference. And then to construct the cubic spline, okay, you need First step, you construct the table. Where is it? This one. Need to construct this one first. Construct this table. Okay. You can, okay, if you want to construct this table, I think using Excel also can or manual also can, because only 3 data. 3 data only. Okay, I think time's up. You can continue here, this one. Okay, that question 20, okay, please continue to construct that natural cubic spline. Natural cubic spline. Because 3 data only, so that table, this table, you may just construct using the calculator, or you want to use Excel, okay, also can. So first you have to construct this table, and then later on to calculate M0 and M2 is always 0 for natural cubic spline, and then you need to calculate for M1 from this okay, formula. Okay, lastly you put up to SK formula. Okay, put K0 to get your S0. Later on, put K equal to 1 to get your S1. Okay, if you got no question, we'll dismiss here and see you next Monday.